Hello, hello everyone. Good evening, everyone. And we are back again. Welcome to We Math World. Welcome to We Math World. Today, in the further one series that we're dealing, we've jumped to conic sections. We just did a bit on probability. We've done a bit on differential equations and all of that. So today, we're looking at conic sections. The reason is because sometimes some people think all of this is very complex. And what does it involve? So we are looking at, we're studying circles. It involves what we call parabola. We have what we call ellipse. Okay, those are the three critical ones. Those are the three critical ones that we're looking at today. So we're looking at the circles, parabola, ellipses. Like I said, like and subscribe, support, follow me, follow me, follow me. And then we have what we call the hyperbola. Now, some critical things that you need to know. For the circle, the eccentricity is equal to 0. E is eccentricity. Eccentricity is how much, what does the word eccentricity means? Very simple. It means how much does the shape bend away from being a circle. Circle, the shape is a circle, so 0% it bends away from being a circle. But for a parabola, it is less than 1. Okay, it's in between there. It's in between greater than 0, less than 1. While for an ellipse, it is equal to 1. While for a hyperbola, it is greater than 1. It is greater than 1. So the eccentricity is just like the shape is getting more curved away from circle. It's first of all a circle. If you are following me, very simple. Now there are equations that follows all of this. But to study the equations, first of all, you need to know how they look. So a circle, now remember when we say conic sections, we are representing these shapes in the two-dimensional Cartesian plane. The two-dimensional Cartesian plane. And the two-dimensional Cartesian plane, we have the x-axis, and this one normally is the y-axis. Okay, so every point on the Cartesian plane has two what values, has the x value and the y value. If it's a three-dimensional shape, each point will have three what values. Okay, so normally it has two values, right? The x and y. So this is point 0. This is center of the circle. Remember this center of the circle. Okay, how do we get what? No, the center of the circle is not the center of the Cartesian plane. That's my point. Okay, are you following? Hello, I hope you are hearing me loud and clear. I really hope you are doing this time around. Well, okay, so we have arrow. Now, one thing you notice is that each of these points, we read it off to this point. So if we say here is A and B, and then we read this off also to the x-axis, right? This is the point A and B. So here, let's say here is the A value and here is the B value. Then this is the value we don't know. Okay, let's just whatever value we want to use to represent it, P, X, and Y. Okay, now this is X, and then this is Y. Now what we'll notice is that from here to here is actually what? X minus A. Is that not so? This is A length. X minus A is from here to here. That's at the bottom. Let me put this well. So at the 0 we have A and B. Here we have X minus A. Do you get how we got X minus A? If this value is A and from here to here is X, what is this value? Okay? If from here to here is A then this x minus a. From here to here is b. In between here will be what? Y minus b. So from here to here is y minus b. So that's y minus b from here to here. Are you seeing it? Now what it gives us is a right angle triangle. Okay? And in the right angle triangle, the radius squared is now equal to this x minus a squared plus y minus b squared. Now take note. In Cartesian geometry, Cartesian, what we mean by Cartesian means in x that has only two dimensions, two-dimensional x and y, okay, which is what we call plane geometry. Okay, so on the plane, we have removed the fact that it's not real, it's not three-dimensional. Normally, everything you design most times is three-dimensional, but this is two-dimensional. That's just the point. So take note of that. So, like I said, this is x minus a. Remember, the first value most times for it is always x value, and then y. It's x and y. So, this is from, how did we get this? Hypotenuse squared, our normal distance, is opposite squared plus adjacent squared. This is exactly what we apply here. Okay, this is a triangle. Okay, this is arrow, this is hypotenuse, it's a right angle triangle. And right angle triangle, we use our Pythagoras rule. Okay, Pythagoras, the wonderful man. Okay, hypotenuse squared is equal to opposite square plus adjacent what squared. So that's exactly what we did. So this hypotenuse is r squared. It's equal to s minus a squared plus y minus b squared. So that's how we do it. So continuing our work, r squared is now equals to, we can open this bracket, x minus a, open the other one, x minus a, that's what it means, plus y minus b, y minus b. Is that not so? So r squared is equals to, open this, x times x is x squared, x times minus a is minus ax, which is nothing, minus 2ax, let's save ourselves that, plus a squared. Okay, this has opened up, so we put our plus here. This is also now y squared minus 2by plus b squared. Remember, it's equals to r squared. All we are dealing with now is for the circle. We have started with the first one, which is circle. And what we want to generate, this is what we call the equation of a circle. The equation of a circle. Right? That's what we're generating. I'm only just breaking it down. Let me wipe this. So we're able to clearly show our working. This one is getting to know. So we have r squared is equal to x squared. We take the like times x plus y. X plus y squared, right? Minus 2ax, right? Minus 2by plus a squared plus b squared. Okay? Now, if we say let a constant c be equal to a squared plus b squared minus r squared, the equation is now, we put this, that means this lives here and comes here. Because no, this is plus. If it crosses the equal to sign, it becomes minus. I think we already know that by now. No, we're dealing with an adult class, not a children class. So there are some things we assume we already know. So x squared plus y squared. But anything I'm assuming that you know that you do not really know, let me know that you do not know it. Alright? Minus 2ax minus 2by plus c is equal to 0. Now this is the equation. Now we can also do a little bit of a trick here. Okay? We can put f and, how we put it now? We can put g and f. They normally do that. But all of that is really not necessary. But take note that with this c is made up of this value, a squared plus b squared minus r squared. Now take note of one thing in factorization. A bit of factorization. We must remember factorization very well if we are to solve conic sections very well, because we are factorizing, right? We broke down something, and then if we are returning back, it will be to factorize it. And we know how to factorize to get a complete square. Do we know how to factorize to get a complete square of any figure? Like I say, x squared plus 3x to make a complete square of it. what do we do? Half of it squared is what you put here. Okay? So it will now be, yo, I hope you are following. X squared plus 3 squared. If you have to find the complete square, putting it, making it into the complete square, what do? We introduce a value x squared plus 3x plus 3 over 2 squared will now be 9 over 4. This will now factorize to give us what? X plus 3 over 2. X plus 3 over 2. Remember, it will be equal to, take notes, whatever you add to this way, it will now, you also add it to the other side. Okay? This is not complete. If we're factorizing this, oh, sorry. Wonderful. So if we're factorizing this normally, we now have x squared plus 3x plus 9 over 4 equal to 9 over 4. Take note, because you have to add it to both sides. One thing in mathematics is that what you do to one side, you must do to the other side. Okay, very compulsory. So this is what we did, is half of this squared. That's how we make this to a complete square. Okay, what now this turns into is now what? X plus 3 over 2 squared is equal to 9 over 4. This is the factorization. This value x squared plus 3x. So this value and this value is the same thing. Okay? This value and this value is the same thing. But now this one is not in square. This one is now only x plus 3 over 2 squared. If this is the value that was given to us to factorize, this will be the answer, right? You can bring this back and put minus there. When you expand this bracket, to give you exactly this. Okay? Okay? Now, take note that r squared normally is outside. So if the formula, if they give you an equation and it's in this form, you should directly now know, indirectly without even much ado, that the value outside is what? Your radius squared. So we know most times we now do what we call comparisons. Okay? Remember how we generated is very simple, from x squared, x minus a squared plus y minus b squared, and so on and so forth. So let's take a question. Let me take a question from among what I have. Let me wipe this. So this is the equation of a circle, right? This is the equation of a circle. But we can also say let f be equal to minus 2a and let g be equals to minus 2b. We want to waste our time, so that we have another equation that is now like x squared plus y squared plus fx plus gx plus c equals to 0. You can choose to do it like this, but this is the equation of the circle. Equation of a circle, right? This value or this value, when we substitute this value into it. Now, this is also the equation. We're only just breaking it down. This is the equation, this is the equation, this is the equation. Based on that, we can actually do substitutions into those values. Gives us those values. Now, let's look at it in a practical form. Solving questions with it, so that I understand what we're doing. Example 1. Examples we have there. So find the equation of a circle. So find the equation of a circle, right? We center 3 and 2. We center 3 and minus 2, okay? And radius of 2. And radius of 2. Okay? So what's the equation? R squared x minus a squared plus y minus b squared. Okay? Now, arrow a and b is given already. A is 3, b is what? Minus 2. So naturally we'll just impute it into this equation. So imputing values into equation, right? Very simple. Put values to the equation. What do we have? We have r, which is 2 squared, is equals to x minus a is 3 squared plus y minus 2. Minus 2 is now turns to what? Plus 2 squared. Okay? So this is the equation. So expanding this, breaking this down, we have 4 equal to what we have just now, x squared. This one times 2 is what? Minus 6x, okay, plus 9, okay, plus y squared plus 4x plus 4, okay. We're expanding this. Remember, the addition of it, that's times 2 is 4, and indeed times 2 is 4. That's the half of it, because it was half before multiplied by 2. So we have 4 outside and 4 inside, and then we have 9. Okay, so this 4 can disappear first of all. Or let's just change the size first of all. So what we have is x squared plus y squared minus 6x. Remember, this is not x, this is y. Plus 4y is equal to this 4 that was outside minus 4 minus 9. Okay. Okay. So all this will give us what? Clear this, just plus 9 is equal to 0. It doesn't understand. We took this 4 and left 0 outside. Okay, and then this 4 cancels this 4, but this 9 remains. So this is the equation of the circle, right? So as simple as that. We didn't even need to come and be computing in on this other side. We just needed to look at it here. Okay, but let us compute it here. In case someone is saying, what about all these numbers to write it here? So let's compute it. What? Here. How do we compute it here? So we have x squared plus y squared, okay, minus 2a. A is what? 3. Okay. Then minus 2b. This minus 2. Minus 2y plus c. Now we know c already, right? This is the value of c. And so we'll put in the value c, a squared. Right? A squared, 3 squared plus minus 2 squared minus 2 squared. Okay, so this is 4. So this c is now equal to 9 plus 4 minus 4. So c is equal to 9. Okay, so we have c equals to what? 9. Based on this solving, is that okay? Are you saying that we are getting back what we got? X squared plus y squared. This is x one. This is now minus 6x. Minus minus is plus 4y plus 9 equals to 0. This is the equation. See, we're back to the same thing. It is as simple as that. So this is conic sections for you. Now, one of the things that we always do in conic sections is that we always find what we call tangent. Tangent to the circle. That's the next thing we're going to deal with. Next I'm going to, but we can also go from the equation to the in reverse. Okay, we have just gone forward. Let's go in reverse. Okay, are you following? Let's go in reverse. But before then, if you have questions, ask. Thank you very much.